microphone right here in the center aisle. Please use the microphone so that everyone can hear the questions. Also, at this time, if you could take some time to silence your mobile devices.
Yeah.
This morning's speakers are first Colonel Scott Jackson, the Chief JIE Solutions Divisions of DISA. In this capacity, he leads two branches that focus on JRSS and Joint Management Systems for the JIE. Colonel Jackson was commissioned in the United States Air Force through ROTC program at the University of South Florida, where he received his bachelor's in electrical engineering. Colonel Jackson also holds a Master's of Science of Computer Systems from LSU. Mr. Chris Medley is with the IP Transport Program, Transport Program Technology Manager, DISA. Mr. Medley has been working with DISA for over 13 years, specializing in technology and communications. Prior to working for DISA, Mr. Medley served in the U.S. Air Force. Mr. Medley holds a BS in Computer Networks and Security from University of Maryland University College. Their full biographies are available through the app if you want to go check them out. Colonel Jackson?
Yep. Thank you. So I guess I'll sit so you can hear me. There's no lapel for me to walk around. I'm much more comfortable if I was walking. So if you start seeing me get up, tell me to sit back down so you can hear me. I took over the JIE Solutions Division at DISA about a year ago. I came in from the Joint Staff, J6, and my background really was tactical comm up until that point. I had a quick stint at WACA where I did some traveling comms with White House. To me, it was just tactical comm in a suit. So working fixed security was definitely a new start for me. I do have some base level background running a comm squadron up at Elmendorf and Richardson. But without further ado, we'll get to the disclaimer statement real quick. I think the lawyers made me do the next slide. Oh, the clicker. Sorry. It's my fault. So here's the disclaimer that these comments are my own, and you can't hold DISA or the federal government responsible for anything I say. That's basically the summary there.
I need that one.
The next slide. So not knowing my audience and seeing a whole bunch of chatter when I sat in your seat last year and watched the JRSS presentation, which was absolutely 100% accurate, but I heard a lot of folks in the background talk about a couple point words, single security, and they didn't hear the word architecture behind it, so they all started, hey, you're making the whole DoD a single security thing, and you break one and you break everything. So I had to take this briefing down, and I noticed it plays much better with the audience in the Pentagon, the congressional leaders I deal with, the GAO. So forgive me if you're the technical ninja. I'm going to bring this way down in case you're not, just to make sure I don't lose anybody with what we're doing on JRSS. So the stack itself, a lot of folks ask me, what's a stack? What's a stack? They want to go see the stack. And I had to step that back for a lot of the folks that I've been briefing, that it's just a series of defenses, defense in depth, based on best practices. So a lot of the actual technology from industry, from financial industry, all went into the Pentagon after September 11th to allow multiple network users with multiple security settings to use the same infrastructure. So in the stack itself, just like, those of you who would do physical security at a bank, you have your actual, vault door, which I've colored here with a red block as a firewall, your intrusion protection system or your time lock. So if your employee themselves has a combo, they still can't get in at 2 o'clock in the morning. Intrusion protection systems, intrusion defense or prevention systems, detection systems like a camera alarm. It's not going to stop anybody from breaking in, but we're going to log it, we're going to see it, we're going to be able to go back to it, which feeds these logs and analytics, which we have ported off on network taps to a lot of offline, out-of-band systems, so an administrator themselves can't go back in and delete logs. I've suffered that in my own career, trying to go back, hey, who changed the system? Oh, that log accidentally got written over, sorry, we don't know now. Even the highest level access in our stack can't do that since we're porting it off to an out-of-band network. And then this by far has been the most discussion we've had. So I put a photo. It may be hard for some of you in the back to see. It's the inside of a vault. It's a bunch of safety deposit boxes. and it's trying to give the analogy of what VRFs are in the stack when we create an individual security zone for the Army, the Navy, the Air Force, and then those sub-zones within. So even if you break into JRSS, you still have to break your way into each individual VRF to get to that particular network. And those settings are still being managed by the people that manage the physical stacks today. So if you're in the Air Force or you're in the Army and you own your TLA, your top-level security stack, and you migrate onto JRSS, your settings in your firewall, router, server, proxy, IDS, IPS, we now virtualize in your VRF, and we just see from above everything that everyone's doing, and you actually, as an Air Force user, have the ability to see what others are doing around you. You can't affect them, but through the out-of-band network with status reporting, you can see if a DISA circuit is down. So when I was tactical, fighting for 3 days, why my network's up, down, thinking it's my stuff. If I had an out-of-band network when I was in Afghanistan and I could have seen that the satellite between location A and location B was up, down, I wouldn't have spent all that time chasing my network. We now provide that to everyone on the stack through the out-of-band network because, of course, if my network went down, I had no way to see above. Now that we're out-of-band, we're able to feed that back down to everyone. So it's a lot of exposure and a lot of visibility to folks, which brings me on that right side, the network management ninjas I put up there. DISA Global, formerly DISA CONUS out of Scott Air Force Base, has the iron view, if you will, the big hardware. They're maintaining the actual devices, the patching, the stigging, visibility of the hardware itself that then the individual virtual machines for each of the services that own a security zone are running on. So they really have that 24/7 visibility. They don't. It's not their job to tell the Army that a switch in a building at Fort Hood is acting up. They would assume that the Army 2nd RCC, who has that responsibility, would go in there and fix it. But certainly they see it, and if they see it happening and not changing for a half a day, they pick up the phone call and say, hey, are you guys looking at your switch? Oh, shoot, we didn't see that. So there is a lot of visibility back and forth, and we're already seeing a lot of goodness. But it's not our intent to take over the world from Scott Air Force Base. A lot of fear about that we're going to go in and change someone's firewall or block someone's access down at especially a tactical level, or right in the middle of trying to launch an aircraft out of Alaska, and somebody's going to reach in there and change stuff. So, but there's complete visibility. So that's really the takeaway from this slide of what JRSS does, its benefits. On the next slide here, this is what's trying to give a level of scope of what JRSS is. So some folks literally thought that the stack was like 2 tower computers that we put on top of each other. When they see it's about 20 racks, and this is a NIPRNet JRSS, this is a SIPRNet JRSS, and I'll talk about the differences in a second. We have these first 5 racks are the main processing that has active failover to a B side. A lot of this is the loggers and the oversight and some of the local storage. And then when I showed you the group of ninjas and the out-of-band network, this is all that management system. And this is, I've tried to match the color coding here back to the previous slide so the technical poker guys could go in and see where their device is and what role it plays. I'll tell you right now, I did this slide, so if I missed something or categorized the box wrong, I'm happy to take the feedback and make it right, but I'll take all the blame and responsibility. None of my engineers did that. But the idea here was to try to show scope and scale of what a JRSS is. It's an incredibly powerful system, very large. This is where we're bringing in migrating a base that has a current security stack, building their virtual zones that a new user to JRSS, an Army unit, but I'll pick on Fort Hood, had their physical stack. They're now on JRSS. Then they go in and reload their individual signatures and settings. That's through all of our migration process. That's why our migration is pretty lengthy. We discover every configuration, every firewall, every proxy, every signature that they may have in a device they're using now. We try to recreate that virtually in their VRF and then hand them the keys and say, you got it. And if they want to go back the next day and block a different port, they now own that inside VRF and their control of their virtual firewall machine for that agency unit at their location. On the SIPRnet side, you'll notice it's a lot smaller. It's 3 racks. Of course, you're on SIPRnet already. It's a protected network, and frankly, we're just really learning our lessons with NIPRnet. And obviously, there's some things in NIPR that we would love to pull over into SIPRnet. But I think we're going to make sure that NIPRnet plays all out, understand what we're doing, get all of our lessons learned, see if there's any consolidation of capabilities to like General Lynn said, get a good deal, and then take that lesson learned over to SIPRnet before we just buy all the same big iron again. Not to knock the iron, the data rates that we're processing with the number of customers, we need that throughput. So unlike I know the whole software-defined everything is coming. We're waiting to make sure that develops at the scale of 40 gigabits or higher when we see it. So we know it'll get there. We know it's just not there for us now to implement JRSS and move folks off. And the real deal, and I didn't talk about it earlier, was to get the 300, 500 individual security stacks to these regional security stacks and get this down to about 50, which helps us, again, get the visibility, save some money, and be able to invest in newer technology, because I'm only buying 50 of those rather than trying to buy 300, get them installed. We can actually, get on that timeline of upgrading IT at a faster pace than what we've currently been able to do. On the next slide, and I'll try to get through this fast so you can hit me with questions. I guess I keep forgetting I'm the slide guy. A lot of discussion about versioning, so JRSS 1, 1.5, 2.0. In a nutshell, what I tell most folks when I brief them, Pentagon level, we wish we could go right to version 5. That'd be great, buy all the best stuff there is. The reality was version 1.0, the yellow box of those systems, was the minimum needed for the Army to do its consolidation of its about 340 bases to get onto JRSS and start using it at or better capability than they currently have at all those bases. 1.5 is not a whole new thing, and I've heard this sitting down in your seats while folks are briefing. There was some impression that we had a 1.0 and we were going to pull the plug on that and build a whole new thing, a F-22 to an F-35. That's not what we're doing. We're adding capability. We're doing tech refresh. We're adding, maybe swapping a one capability for another to give increased ability for now the Air Force to migrate their gateways onto JRSS. So 1.5 was aimed at those minimum things the Air Force asked us to have before they come off of what security stacks they're managing at their own bases. And the 2.0 capability really aimed at getting the Navy and the Marine Corps, because they had just done a tech refresh to their B1s and B2 stacks. So they had a few extra things that they wanted us to have in. So that's how we phase this in. Get the Army with 1.0, get the Air Force with 1.5, and then get the Navy and the Marine Corps by the time we get to a 2.0 version. My budgeting and my execution and timeline plan is all mapped for that same thing. Get the Army done, hopefully, in the next year or so. Then the Air Force finishes out by the end of fiscal 17, and then the Navy's coming in after that. The last slide I think I'm going to talk to is this one, which is basically the summary slide, the takeaway, why we're doing it, make sure that we can actually shrink that domain and get some savings out of it. And I think I've chewed up all 30 minutes that I thought I was going to be faster. So I think that's it. I should put the call out. Folks are going to ask me what's in there. This is the list of the current devices that we have associated with JRSS, NIPR, SIPR. The contract support that I currently have on the right, and then all the equipment. It probably isn't the latest and greatest update. If I'm missing one or two that we just procured, forgive me. But I'm happy to add that if you see yourself, hey, we think we're in there. Definitely was not an overt or it would be a mistake, I guess, what I'm trying to get to. So these are our partners who are helping me in the stack. And at that point, I'll take your questions. Fire away. And I do have technical help in the audience, so if you get too technical poker on me, I have a phone a friend. So, sir. So I mean, I can repeat. So the question is, how does coming onto JRSS affect the IA posture of Army's current TLA stack with their accreditation coming onto JRSS? So we've done the type accreditation for the system to show that we now have the same level or better protection. Our risk management executive signs off on the iron, if you will, the hardware. You know, that if configured right, it does its job. Now the Army would come in, inherit a lot of our RMF controls to do their accreditation, but the Army still is the one going in and setting their firewall rule. So if an Army policy says you must have port 27 blocked, you know, that's up to the Army to then, no different than what they do now. So their existing processes for their hardware, we're trying to take the burden off of patching and stigging the box, and then they can focus on setting their signatures and their actual device settings for their virtual framework. Does that answer your question? Yeah, there is a mic in the middle so everybody can hear your question. So the question about how do the industry partners get involved, I'm not sure if you were in Mr. Montemurano's brief, he touched on it a little bit that we're currently using the existing contract vehicles that have multiple vendors on them, and I'd hate to list one because I'm sure I'll miss him. He had a whole slide of well, I'll say a couple, but forgive me if I don't have all of them right. So NASA SOUP, ETI, GSMO. So within those contracts, and there's a couple others, Encore 3, you know, he had that whole slide of them. It's in the briefing slide. I know you can go get those decks. But inside those briefings, inside those contract vehicles, there's primes, and then those primes go to a lot of subs, right? So very easy if you come to me and you say, hey, I have a capability, and I'm already a partner with company X, who's already a prime on NASA SOUP, and this is how you can get to me. So if not, then we're not sure how we're easily. Now it doesn't mean we can't. It doesn't mean we can't start from zero, but it's a lot harder if it's a new contract. It's not one of those already packaged vehicles that DISA uses a lot. Now there's others out there in the federal government, and you can steer me to, hey, over in the federal space out in Tennessee Valley Authority, we're on one of their contracts. But if it's not something DISA is using on a day-to-day basis, you're making a start from ground zero, working through our DITCO contracting, all the legal reviews to know that we can use it. So that's the assuming there's a capability that we're after, and that version 1.5, 2.0, that's really trying to set that expectation of I'm not out there buying rocket ships yet, right? We are just trying to match Army, then Air Force, then Navy at our same capability, get them all to consolidate so we get them all, use that savings instead of having them go out and buy 300 of something. There's savings in the department to then get what we're really, I think after, which is that cutting edge, speed to need, technology that General Lynn was talking about yesterday. And hopefully the message is interwoven now. The budget and where we got to go with cybersecurity, we're trying to find a way to shrink down to a consolidation regional stacks that I don't have to go buy 300, 700 of something that's going to take me 2 years to implement that then is obsolete by the time I'm ready to hit FOC. So I'm trying to get down to 25 or 50 of those so we can rapidly turn it, save the money, and be able to execute things faster. So I know I walked kind of around there, but hopefully that answered your question.
A great presentation. I learned a lot. Quick question for you. So today's JRSS stack has a lot of great security capabilities, firewall capabilities around data and applications. However, with the rise of unified communications, real-time SIP traffic, there's kind of an inherent risk with new vulnerabilities and threats that are specific to that real-time type of traffic. Is there a plan to augment the security capability, the firewall capability to protect against that real-time traffic threat?
So I'm not sure I'm tracking the question yet. Now I am looking to my engineer, phone a friend, if you're tracking the question. I don't know I'm with you on. So real-time versus...
So real-time being SIP-based traffic, so voice calls, things like that.
Yeah, So my phone a friend is telling me that, we're, of course, the way that we're sliced and diced, and maybe I should have quickly went through this. I'm gonna walk around the block too to get to your question, and if I don't get it, I'm gonna hook you up with Eli, my engineer. So JRSS is what I would call the midpoint security level, and if we did a physical analogy, and it's actually the next slide I'm working on to kind of walk through, physical security for a base starts all the way at the wall, on the border, right, and the radar that sees a Soviet bomber coming over. We don't do that, and neither does a base, right? And then you get down to your local, federal, state police and FBI watching crime in the area, and now you're at the base gate. You're at Elmendorf Air Force Base in Alaska, and the base guard, looks at your ID and makes sure your car is good enough to drive in. So JRSS is at that midpoint. Once you're on base, if you all of a sudden, you're a valid military user and you decide to go rogue and break into the exchange and tear through the cash register, the base guard doesn't leave his post to then respond to the exchange, the BX, and stop that. So I think what you're getting at is down at the voice session level, where we hand that off to a local, what I would call intra-base, the endpoint security, and I'm dancing around, but if it's not helping you with where I am in the stack.
I think he was saying the key terms, so I'll follow up with
I'll let you and Eli chat about that. But I think the bottom line is not our focus right now. Is that,
I'll talk to Eli. Thanks.
Yep.
Is there any more questions at this time?
So that's 1 point for technical poker wins, by the way. I'm keeping score.
Thank you for the presentation. What is the relationship between the stack and the KOCs and the CRCs as you go down toward the tactical
Yep.
deployment?
So, of course, being a tactical guy, very near and dear to my heart, and I'm trying to see, I saw some of those guys run around the audience earlier. Again, at that midpoint security, if you go into the KOC, they have a security stack at IUD right now. So the idea is any of the security, firewall, IPS, IDS functions they're doing through their local network control will swing over to a JRSS regional stack, will free up that funding for the KOC to now look at other investments that they can put into maybe more social media, which they're getting hit with, whatever their priority is, because we're trying to alleviate the need for them to worry about those devices at the midpoint. So we absolutely are. I was just over in Qatar about a month ago working with the deployed folks. We have 2 stacks planned for Southwest Asia. So the tactical units will migrate in. The roving tactical units, the disadvantaged users, still take their own. So when I was at Combat Com, I still took some stuff with me. I plugged back into a step site or a teleport site that had some security. Then that plugged back into my service or my COCOM. We're not changing that yet. So we're trying to just get the savings from all the fixed security stacks, including the ones at those forward locations, so they can stop, or they can alleviate some of that burden and have DISA Global kind of be in their watch. So we're hoping to give them a little bit more of a you can focus, no kidding, on your theater, Syria, Iraq, Afghanistan. Let us worry about that phishing, spam, malware threat that's coming in from the back door. Does that help?
Yes, thank you.
Sir.
You spoke briefly on the accreditation process. Now, as far as vehicles go, to verify that software, the SDN, and actual hardware are able to be sticked properly and be effective against cyber defense, what's your vehicles for hitting that dial?
So I maintain within DISA a team that does both the config management to make sure that we're keeping up with it, the research going out, looking at the latest STIGs, the policies, the IAVMs, and then we have a tier 3 vendor that actually does it for me to keep the lab stack at Fort Meade updated and patched with the latest. Now, some of them, if there's a STIG or an IAVA that may break something, we may say, we've done the research, and because we're a little bit more bleeding edge than maybe some of the places it was tested, we need to wait for that to be resolved. But the bottom line is we have a lab at Fort Meade with a complete JRSS stack. We do all of the config management, the testing, the IAVA patch STIG research, all done there, tracked. It's then ported out to the out-of-band management system where everyone can see, and then those are ported off to the production environment. We have Big Fix and Red Seal are the devices that are gathering the data and watching what's going on out in the field. And, of course, those tool sets are, again, being used by DISA Global. So if someone doesn't STIG their box out in, I don't want to pick on Fort Hood again, Robbins Air Force Base, you now have the visibility from CONUS or Air Force to go down deeper and deeper and deeper and see that, hey, this Air Force base is not set the same way this Army base was. We never had that before. There's no way at 700 stack locations you could look across with 50 stacks or 25 physical sites. DISA Global now shares that openly, and with a lot of eyes on it, asking, hey, why is that not to the same level as this lab? Hopefully that hits it. And again, if not, I got to phone a friend. So, how am I doing on time?
Thank you, Colonel Jackson, for your remarks. It's time to switch over.
Kick over to Chris there.
Appreciate your time and your informative remarks. Mr. Medley?
Okay. The first problem would be, it works. Good morning, everybody. I don't know if I have a disclaimer slide, but people who know me know that I need one. So, you can go to the next slide, please. Or I can.
Clicker. Red button.
Red button.
You want me to click for you?
Oh,
It's the big right arrow.
that one?
No, the big right arrow. This guy right here.
That's the first one I pushed.
But you got into...
And I can do MPLS.
You hit escape, and then he'll be able to click again. You hit some other button that got you into where to go. Now hit it.
Now hit it.
Arrow.
I have a disclaimer. Whew. It matches his. Not going to read it. Okay, what in the world is MPLS? And the M does stand for magic, by the way. And I also don't feel comfortable sitting down, and I wish I could stand up, but I won't. So MPLS is a technology. We're enabling new methods of providing service, and it's transformational, really, to the whole DISN. We currently provide MPLS across some of our existing legacy platforms, and I'll get a little bit more to that later as far as why this MPLS is better. MPLS is a protocol, high performance, virtual traffic separation. It's actually a switch network in the middle, so we're actually cutting down on the routing time as we move more traffic to serve JRSS and our many other missions that we're providing. And just to confuse matters more, we called the project MPLS because we couldn't get enough MPLS. So this is the least technical slide I have. It's only going to get worse from here. If you don't have coffee, you should get some. So MPLS is, what do we do? So we have a packet or a frame or some kind of data that comes in from an external service. And really, if you look down here, if I get the right button, so we got the data and that is whatever comes in. It could be a packet from another network, from an IP network, could be an ATM cell, and so typically 1,500 bytes or so, but it could be anywhere from 50 to 9,000 bytes for a single packet. So what we do is we take that packet. Of course, it has all kinds of different kinds of headers on it that could be different sizes, and instead of worrying about the header, we slap an MPLS label on there that's 32 bits. It's always 32 bits. It's never 31, never 33. And so that 32 bits is basically the address label, the standardized address label that we use to express this packet through the network. And really, it's very simple. There's a label number. 20 bits is the label number, which gives us over 1 million possible label switch paths, which is basically all the different paths that the MPLS or that the data can take. Then I have 3 bits that I use for quality of service, 1 bit for the stack, which I don't know what that is, but I got engineers who can tell me. And then time to live, 8 bits for that time to live. And so really what it boils down to is we're not using any of the IP information that comes from the external network. So we don't depend on it. We don't share routing with it. We pick it up, we carry it, we drop it off, we don't look at it, and that gives us a lot of freedom, a lot of power, a lot of security. And I was going to point out that we use really technical terms in MPLS, and we have the 2 terms for adding and subtracting these labels are push and pop, and we can't get more difficult than that. So next slide is this one. So what do? We do virtual private networks. We can do that. We can do your normal VPN. You have an app on your laptop that connects, and you have data that's guaranteed separation. We do that. But what we do even more is we do virtualization. And virtualization is really the foundation of all the efficiencies that we can get from this platform. We can allow multiple instances of routing tables. So while I say we don't have to share routing tables with an external network, we can. We can pick that up. We can encapsulate it into a virtual router and forwarding instance. So basically what we can do is we can take the physical hardware that a customer has, and we can virtualize that hardware within our network and keep it separated from all the other virtual routers and all the other traffic simultaneously. So by doing that, we have a big problem. If anybody here knows about installing equipment, you have a big problem at sites to find your power, to find your space. And so we're replacing all those routers, which I'll show you later, both DISA routers and customer routers, and basically putting all those in one box and really helping the whole thing off. And so another piece of this is that if we remove that dependency of each network, each individual community of interest network on its own hardware, as soon as I introduce that community interest network into any point in the network, it's instantaneously available at all other points. I don't have to go out and field a new router, new kind of interface, new hardware all the time. Of course, as we upgrade, we'll never win the hardware race. But what this does do is it gives me instantaneous access anywhere in the world. And if I put a service anywhere in a DEC or a CDC or anywhere else, I can immediately have that available anywhere else. Okay, so we have quality of service, and we just reserve 8 bits for that quality of service in that MPLS label. And the point is one of the important things is this is the MPLS quality of service. We're not changing the customer's quality of service. We're not modifying it. We're not dropping it. I'm not even sure if we're reading it. So we can use it, but we don't need to modify it. And like I say, it's 8 labels. The highest priority label is TDM. That's for circuit emulation. We can't drop that. We have to keep. That really does go to the top of the pile. And what's over here on the baseline, that's what we expect to see. We're not limited to that. So it's not like we're taking 10% of our bandwidth and saying you must be MPLS and you couldn't go to 11%. But really this is what we kind of see of the expected baseline of how the quality of service. So label switch paths, right? So I say, well, so this is IP transport. We call it MPLS, but really what it is it's packet transport. And we brought in the best features of TDM and IP really goes into MPLS. We've got TDM because we can set paths right up front, and all the data in a connection takes the same path. So we're not going to get it reordered as long as the network's running well. You got everything on the same path. So you're not going to get the frames out of order. We pick them up and we drop them off in the same order. We can through the QoS we got the real-time traffic requirements covered. We basically MPLS is magic. I don't know. So really, what we pick those things up, we take them, we drop them off, and we don't really need to mess with them at all outside of just reading that label. So this button doesn't work every time. So at the layer 2, so we had the virtual routing and forwarding where we can actually pick up customers. We can actually substitute a customer's routing. We also do, basically, we can pick up, we have a circuit, a pseudo wire, and we carry these bits point to point. And again, we don't need to signal with the external network. We don't need to share routing tables with the external network. To that network, we simply look like a big, long Ethernet cable. And any traffic or any transport over MPLS just points out that I'm not just IP. I can pick up Ethernet. I can take ETM, which we're doing, and I'll get a little bit to that later. Frame relay, I'm not aware if we're doing that, but we can. And really, it boils down to we're really agnostic to the traffic we pick up. As long as I have an interface, I can pick up that traffic, I can carry it, I can drop it off, and I don't have to wait for IP routing or any of this. So what are we buying? What kind of features? We figured since we named the project MPLS, we would buy routers that had MPLS. But what we're looking at is, I'm not looking at specific brand of router or anything else. I'm looking at common technology levels. And what I got to before is that we are doing MPLS now, but in there, and I'll show you a little bit later on, but we have a lot of different platforms, and what this is a standardized platform, standardized on requirements, not standardized on equipment. Backplanes, multi-terabit. We have non-blocking capabilities. We have 100 gig capabilities that we're requiring in our equipment on the core. High density interfaces. So basically, I'm looking for cards with many ports, so I don't waste those slots. And then we need circuit emulation because while we are moving into IP, not everybody's there yet. So we have to actually do circuit emulation in the way of E1, T1s so we can carry a lot of these circuits on legacy systems that aren't going to be replaced anytime soon. So we're going to have to buy all this equipment. We're going to get it installed in the racks, but then we have a problem. We got to manage our ports. We got to limit the number of interface types. There's a lot of different cards available for these routers. There's DS3 cards and OC3 cards. But if we slap all these different kinds of cards into these routers, I'm going to fill up these slots very quickly, and I'm not going to get to that standardized platform that I want. So I'm limiting those interface types, and we're encouraging use of sub-interfaces. So if a customer's bringing me, if a customer's going to bring me an Ethernet cable, why not virtualize their services on that cable before they bring it to me? It lowers their cost. It lowers the cost of the network. It helps everybody out. Circuit emulation, why I can do it. This is not where we're trying to go. I'm not trying to build another TDM network with this effort. Obviously, we know we have to do it, but as time goes on, it's going to be more and more justification that somebody's going to have to give us to do more circuit emulation. And one of the things we have to do is we've got to stay away from the vendor features. And while they're all going to tell us, all the vendors are going to say, yeah, this router does this and it's great and new and everything else, we can't use it because as a standardized platform, I can't depend on a feature for a circuit that's going to go around the world and terminate on a different brand of router. And of course, testing and everything else, the more of these features that we use, the harder everything gets to keep this platform standard and flat like we want it to be. Okay, I'm not as smart. So this is what we're doing here. We're taking all these, and we call this the bubblegum chart. So Promina elimination. I don't know if everybody here knows what a Promina is. It's a low-speed TDM box. It actually carries some pretty important circuits and a lot of emergency action method circuit. These kind of traffic. So we can't just turn it off. Company is soon not to make it anymore. So we gotta have a replacement. So this is one of the tools. IP transport is one of the tools to replace that for those circuits that cannot leave the TDM world and come straight to IP. Datums elimination. Datums is all but eliminated in June. It looks like it's going to be done. So I said I'm carrying ATM. Right now I'm carrying ATM for the Prominas because the Prominas did connect to ATM. So we have ATM cards connecting to those Prominas, so I can carry that through circuit emulation until we can get those Prominas out of the network. I'm replacing the edge routers for the NIPRNet, the UPEs, the UARs. Basically, those are going into virtual routing, and all the approvals aren't done yet, but we're well on a path to get that all done. So we are eating our own dog food. We're not just selling virtualization to others. We're virtualizing our own services as well. The CPEs are actually the first one. These are the classified provider edge routers. We're actually doing this now. We're moving those CPEs. And of course, I'm carrying JRSS. I'm a little bit important to them. I like to think I am anyway. And on top of that, I have MNIS, multinational support. We're looking at doing the MedCoy in the VERF. We actually have quite a few other missions beyond what's listed on this page. So here's what our network looks like now. And today we have a lot of physical boxes that were needed at the time based on the security posture and really the capability of the routers in some cases. And if you look at the today, that goes and shows many of the routers that we're using now. And if you go between the today and the mid and the short term, you see that IP transport edging in there. And as we go to the midterm, then basically all of those DISA services, and this only represents the current DISA services, will move to virtualization. And what that gives us is, of course, beyond the efficiencies that I just already said as far as site power and really just collapsing down the amount of hardware out there and the OpEx for operating it, and then the eventual refresh for the money to take to replace all those routers. We're increasing our agility. So basically, I can, like I said, we can take any service, we can put it anywhere in the cloud that as long as those routers are there, and we're decreasing the number of attack surfaces. So in a way, we're streamlining everything in many of the same ways that JRSS is, and kind of reducing our risks at the same time. And so this only stops at the midterm. The long term goes, of course, into software-defined networking. So I am the on-ramp to software-defined networking, and these routers are kind of the first piece of that. We can't get there until we can converge in our own network. So basically, it's both the convergence and the equipment. The equipment, of course, can be run by many of the same controllers that software-defined networking will bring us. So transport demand. So our transport, we can't, at the current moment, our transport is mostly TDM now. So if you look on the left side, really all these lines that go up on the left, they're all different transport paths, and they could either be leases or they can be optical transport on GFE, equipment that DISA owns now. And really what's happening is that as we move towards that midterm, we're reducing that load on transport over here to where so each one of these, and you have an administrative cost for their leases, you have an actual lease cost. So we're gaining those efficiencies because if you look at that, that's nailed up bandwidth. So it's allocated bandwidth, and if we're using it and moving bits, great. But if no bits are moving, that bandwidth is sitting there empty, and nobody else can use it. So as we get to that convergence and we shrink down those paths, then everybody can have the efficiencies of that increased bandwidth that we're using. So the cost base, the cost savings, I think, are pretty obvious here. And our port demand for our own equipment is also a big cost savings. So why are we doing this? We're getting to that everything over IP, and I think we've been talking about everything over IP for about as long as I've been in the military doing comm. And really, as everything over IP, if we use like the legacy infrastructures, it's not really so possible, because as we increase the number of networks that we're trying to support on single pieces of equipment, we're dramatically increasing all the routing tables that we'd have to look at. We're dramatically increasing all the attack surfaces that are possible. So really, it's not everything over IP, in my opinion. It's everything over MPLS, and it's not really my opinion. It's one of my engineers' opinion. But it's everything over MPLS is where we're going, because we can keep that traffic separated. We don't have to have mega routing tables, and we pick up the traffic again. We label it, we move it, and we slap it out the other end. We don't have to expose our network to others, and we don't have to see their network. So really, this is the sort of the project scope, and I'm not going to read this whole thing but mid FY19 is our goal to get all this done. I'm fully funded. I'll show you on the next slide. By 18, we're really on our way to making that possible. And I'll show you how that's possible if we can get there. So where am I now? And at the moment, if you look on each one of so my slide is actually a little bit different. But we have 27 complete Anconas, 27 routers, or 30 on that slide, and I have 11 single routers. And a single router, so we have dual routers, as I showed you in the other slide, but really I have a site prep issues of power, lack of connectivity that's keeping me at those 11 sites in Conus from turning up the second router. The router's there. In a couple cases, we are waiting on Milcon, so that router's not there. But when the Milcon comes in, we'll get that done. So I have 4 sites complete, or 5 complete in Europe, and I have 1 single site. I have all 6 DSS sites, Business Subscription Service sites, complete in SWA. And I have 5 single routers in PAC, and I have 18 funded for this year. And on the bottom left, by theater, from now until 18, it'll show what we are planning to install, what our objective is. That actually totals all the way to the 337 current sites in the Business Subscription Service. Not to say that's not all the sites we're doing, because both the Air Force and the Navy, or the Army and the Navy so far, have actually funded other sites that are not Business Subscription Service sites. But for the purpose of this briefing, I stick to that. So I hope I didn't bore you too bad. That's really all that I have right now, and I can take any questions.
If you have any questions, please come up to the mic.
Okay.
All right. Thank you, Mr. Medley. And again, thank you, Colonel Jackson. Both your briefs were very good, very informative. I appreciate your time. Thank you.
Thank you.